This is the recap of Singapore JavaScript interview meetup on August 25th. The first question is a LeetCode question. Given two strings, find the minimum window in S. By window, it just means substring. Find the minimum window in S that contains all the characters in T. Now you do not have to maintain the same order. For example, B and C, this is a window within S. It doesn't have to be the same order as ABC. So some of the other valid windows is ADOBEC. You can also include this D. You can have BECODEBA. But of all these windows, we want to find the minimum of it, meaning the length should be the shortest. Your T can have duplicates, so you can have multiple A's, multiple B's, multiple C's. It's just in this case, it's unique. Pause the video and see if you can solve it. What is the intuition behind this question? The intuition is pretty simple. We want to find a valid window. For now, let's not concern about the minimum window. Let's just say, how shall we identify this is a valid window? Once we identify a valid window, we start shrinking it until we can't shrink it anymore. So if you have a window like this, you start shrinking, so you shrink from the front, it will become like this. It's not valid anymore. Once it's not valid anymore, you start expanding again. So you start expanding all the way until where are you valid again? When you reach another A. So when you are this window, you are valid again. You start shrinking again, you start shrinking from the front. So you shrink will become like this. You are still valid. So start shrinking. Is this valid? It is still valid. You shrink until here. This is valid, but if you shrink again, it's not valid anymore. So if it is not valid anymore, you start expanding again until the end. This is a valid window. You start shrinking, shrink, shrink, all the way until you reach B, A, and C. So let us set it up. Loop through. My R represents right index, and L represents the left index of the window. R cannot be out of bound. Expand to find a valid window. If valid, shrink till invalid or can't shrink anymore. Also update result because it is a valid window. How do we know if a window is valid? We can have a count map that keeps track of how many each characters do we need to match. For example, ABC, we need to match A1s, B1s, C1s. If you have A, B, B, C, C, you need to match A twice, B twice, C twice. So we can have a count map. It's an array of 128. Fill it up with 0 for const char of T plus count map char dot char code and. If you're familiar with ASCII table, each character will map to a decimal value that's less than 127. So a capital A will map to 65, same as B, same as C. So in our case, a capital ABC will increment the position of 65 to 67 by 1. All the rest of the array will be 0. That's what this line does. We are keeping track of the count of each character. If there are no characters there, it's default to 0 because we fill it up as 0. This should be square bracket. Okay, how do we know our current window is a valid window? We can have another window called window, another array called window, initialized to 0, and we fill it up as we visit each character. As we are visiting the character at position R, remember R is the right index, we increment it. Increment the window at the position s.char code at R. So let's have a helper function that tells us is valid. It's going to take in two things: the count map, where the count map is what we should match, and the window is the current window. So when is it valid? Let's see when is it not valid. We look through all 128. If the window I is less than count map I, is considered you match less than what is minimum required. Return false. You can have more, but you can't have less. If you fulfill all 128, you return true. I think there should be a bracket here. Okay. So the idea is, if you're valid, we just keep shrinking. We can use a while loop. While is valid, count map and window. Our left index also needs to be less than equal to a right index, because left should be to the left or right. We update the result. Now here you can have a result string and keep overriding it as long as the current window has shorter length than the result string. But string slicing is actually expensive, so instead of initializing a string, I'm actually going to initialize the index. I'm going to call it low and high. My -1 meaning it's not a valid index. It also signals to me it has never been written before. So if my low is less than 0, I should write it. Low will be left index, high will be the right index. Else, I should only override it when the current window has a shorter length. So my right minus left is shorter than high minus low. So here we are updating the result. Where low and high represent final result index. They are both inclusive range. Now we need to shrink it. Now before we shrink, we should decrement the count at the index of left, because we are shrinking the left. Basically, we do the reverse of this. When we expand, we are expanding on the right, so you plus the position on the right. But when we shrink, we minus, and we shrink the left. Then we plus left. If you want, you can put plus here. It has to be post-increment. You cannot put it as pre-increment. It has to be post-increment. Now the final result will be, if low is less than 0, meaning it is not a valid index, meaning there's no valid window anywhere, we return an empty string. Else we return the substring of low, high, +1, because This is actually an exclusive range. So it works. The time complexity for this code is O of n. It's linear. Your outer while loop, the index r will travel through the string once, although you have an inner while loop, but inner while loop left will be upper bound by r, and once left is advancing to the right, it will never be set back again. So left will also traverse through the string once. You essentially have two linear or two O of n, which is O of n. Although it is O of n is not optimized, specifically this isValid function will check for 128 times. I know you have early stopping, but still, this is not optimized. However, I must stress that the optimized solution is pretty complicated. It took me quite a while to figure it out. So I'm not going to go in depth into that. Instead, I'm just going to give you the solution and a very brief explanation. So instead of using this isValid, let's get rid of it. We will use a variable called toMatch. Let's initialize it to the length of the word we want to match. So ABC, length is 3. We have 3 to match. Instead of saying isValid, we will say as long as there's nothing else to match, it is valid. It's the same concept. We will not use the current window array. Instead, we will operate on the same array, which is countMap. So this line is not valid. This line is not valid anymore. Expand to find a valid window. Previously, we are incrementing window. But now, since we are operating on the same count map, we can do the opposite of plus plus. We can do minus minus. s.char code at r. To make it more readable, let us do r. You can think of this as we are initializing how many counts we are missing or how many we are yet to match. But inside this for loop, whenever we are visiting index r, we are fulfilling the count. However, we are only fulfilling the count if there is a count there. Count map r greater than 0 minus minus to match. This means you have fulfilled one of the count. You can also do to match minus minus this condition. Minus equal to that condition. Now, how do we shrink the window? We will do the reverse of this. Instead of shrink, now we should shrink the left. Our to match will plus equal to left greater than equal to 0. Plus plus count of left and plus plus left. Let's see if it works. Now, why is this greater or equal to? Let me ask you, what does 0 represent? 0 represents my current window has exactly the same count as what is desirable, right? For example, if my window is this, my window has A ones. What is desired is A ones. Now, if I shrink it, I will have less than what is required. So if you're at 0, your to match will increment by 1. What does a positive count map L represent? it means in the current window, you have less than what is required. So if you shrink that, you have even one less than what is required. Again, it gets pretty complicated, so I'm gonna stop here. Let me submit and see what is correct. So there we go.